Today we are going to do our unit on congruent triangles. Okay, here's our meme for today. I apologize in advance if you hear any noise in the background. Henry's here helping out. As you can just see, he's writing on the board. So, meme for the day. We are talking about, can you know the difference about triangles? So equilateral, okay, isosceles, scalene, and then some little kid is asking or saying you forgot about Bermuda. Okay, we are going to just briefly talk about what our proof without words would be. Our proof without words would entail you taking a piece of paper and cutting out a triangle. Okay. We would then fold all of our edges of our triangle together so that the points meet. Those points would then meet on a single line, proving then without words that our triangle has 180 degrees in it. We'll do this activity once I return.
Hi.
Hello. Our next slide then is asking us to list triangles in two main categories: by side and angles. Go ahead, make a list in your notes right now, pause the video, see what you can come up with, and then our next slide shows all of our options. You're gonna notice the top line is everything by sides. So we have scalene, isosceles, and equilateral. Notice that the small, short definitions are underneath. Hello. Then we're gonna classify triangles by angles: acute, right, obtuse, or equiangular. Notice equiangular might be a new one for you. It's where all of the angles are the same. Many of you will probably argue that it's the same as equilateral. It is, okay? One is just by sides and one is by angles. When we talk about triangles, we like to use capital letters to represent the vertices. So this would be called triangle ABC. And notice that the sides, there's a couple different ways to do that. When I talk about triangle ABC, I can use the triangle symbol to do shorthand. When I talk about the sides, I am going to use lowercase letters, and they will be opposite the capital letters that make up the angles. I can talk about the sides as either side C, or I can talk about it as side AB, but they are referred to as segments. So it would be side AB, side BC, and side CA. From here, we are then going to talk about how knowing the definitions of our triangles can really help us be successful in solving for unknowns. So this particular triangle, STR, is an equilateral triangle. So I will mark it as so. Since I've marked the sides equal, I can then take two of them, set them equal to each other, and I can preliminarily solve for x. Then from there, it says that I have to find the length of each side. Since it's an equilateral, I just need to find 1. And I would have the measurement for all of my triangles. Henry just changed the slide on me. So, going back to here, we have x is equal to 9, and our side is 18 units. Now, what happens when they give us 3 points? Okay, we're going to have to use the distance formula, and we're going to have to use slope. I'm going to label this as point A, B, C. You need to find the distance of AB. Excuse me, I miswrote that. You need to find AB, you need to find BC, and you need to find AC. Once you find those distances, you can get the name of your triangle by its side. The only angle that we would be able to determine is if we have a perpendicular angle, and we do that by slope. So just double checking, if you've done your distance, AB should roughly be 7.07, BC should be 6.7, and AC is 2.24. That makes it a scalene. if I go through and I do my slopes, so slope of AB, my slope of BC, my slope of AC, I'll end up with 0.14, 0.5, and -2. And that then means that I have a perpendicular set of lines here. So this is a right scalene. Let's take a look at our first theorem for our triangles here. So when we are talking about our theorem, this says that all exterior angles are formed by extending one side of a triangle, okay? And that the exterior angle will be equal to the two remote interior angles. Again, I'm sorry, that's Henry. So what does that actually mean? That means that angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So I can find my measure for angle 4 by adding the two far interior angles. If you want the theorem directly from the book, okay, this is our theorem. Okay. If you want, again, pause the video to write down what you need. We're going to practice. So in this particular instance, if I wanted to find the value of x and interior and exterior angle, okay, what I would need to do is to find this angle here, I would sum these two together. So I would have my value of 2x minus 5 equal to x plus 70. I would get my value of x to be 75. Then I can plug back in and find that my exterior angle then would end up being 145. From here, let's do another example. And we are going to, again, do the same thing. We'll notice that our two interior angles should sum to our exterior. For this one in particular, we should get x to be 25, and we would get our interior angle to be 65. There's one last corollary to kind of remind us that when we are working with angles, okay, there can be at most one right angle and one obtuse angle in a triangle. That brings us to our objective for today. If you have questions, please talk amongst yourselves and problem solve and ask us for the note.